Welcome to The Explainer. Today, we're diving into something huge, the new algorithms that are set to totally revolutionize healthcare.
You know, for years, we've heard this buzzword, big data in medicine. But here's the thing. What if the real story isn't the data itself? What if it's the algorithms, the powerful new tools that can finally make sense of it all? That's what we're digging into.
Okay, so to really get a grip on this shift, we've got to look at how this new kind of AI is just fundamentally different from the old way of doing things. So you have the old AI systems, right? They're called expert systems. And you can think of them like med students. They're just memorizing rules from a textbook super meticulously. They can only do what they've been explicitly told. But machine learning? That's a whole different ballgame. It's more like a resident doctor who's learning on the job, directly from experience, by looking at thousands, even millions of real patient cases. So what is machine learning exactly? Well, imagine it's a detective that can sift through literally millions of clues to find that one piece of evidence that cracks the case. In medicine, all those clues, that's our patient data. And the mystery it's trying to solve is predicting how a disease is going to play out.
All right, let's make this real. Think about a chest x-ray. The traditional way of doing things, you're relying completely on what the radiologist writes in their summary. You know, a couple of key words. But what if the model could just see the x-ray for itself?
And that's where things get really cool. See, a machine learning model, it doesn't even need that summary. It goes straight to the source, looking directly at the raw data. We're talking millions of individual pixels that make up that image. It literally teaches itself to spot the patterns, those subtle shadows and shapes that even a trained human eye could miss. It's all about letting the data tell its own story.
Okay, but let's not get ahead of ourselves. This powerful new approach, it isn't a silver bullet. There are some very real risks and, major challenges we have to be aware of.
Yeah, there are three big pitfalls we really need to watch out for here. The first is something called overfitting. This is where the algorithm gets fooled by a random pattern, basically a fluke in the data that doesn't actually hold up in the real world. Second, these models are incredibly data hungry. I mean, they need absolutely massive amounts of high-quality data to work well. And third, it's that classic trap we've all heard about. Correlation is not causation. Just because an algorithm can predict something doesn't mean it understands why it's happening.
So getting around those challenges is absolutely crucial, because once we do, and once these models are properly validated, this technology is poised to completely disrupt at least three key areas of medicine.
All right, first up, it's going to radically improve how we predict a patient's future. For people with serious illnesses like cancer, this could pretty much take the guesswork out of prognosis.
And check this out. This shows just how incredibly precise these models can be. One study, for instance, looked at cancer patients and was able to pinpoint groups with a near 100% mortality rate, while also identifying other groups with a rate as low as 10%. I mean, that level of accuracy? It's a total game changer for everything from treatment plans to end-of-life care.
Okay, so disruption number 2, it's coming for fields like radiology and pathology. Basically, any specialty where doctors spend their time interpreting images, like MRIs or tissue samples.
And the reason why is pretty simple, right? An algorithm never gets tired. Its accuracy, its vigilance, it's exactly the same at 2 in the morning as it is at 9 a.m. That's a huge deal. It's why we're already seeing algorithms being used to provide that critical second read on things like mammograms.
And number 3, machine learning is gearing up to tackle one of the absolute biggest and most stubborn problems in all of medicine, diagnostic errors.
Just imagine this for a second. An algorithm that listens to a patient's symptoms and, boom, instantly generates a list of possible diagnoses. And it doesn't stop there. It could then suggest the highest value test to run, helping cut down on all those unnecessary and often expensive procedures. This is the future of diagnostics, a super powerful assistant working alongside our doctors.
So, you put it all together, better predictions, more accurate readings, fewer errors. It's all on the horizon. Which brings us to the big question, who really wins from this incredible technological leap?
Well, according to the thinking here, the biggest winners are going to be the patients, us, the very people whose data, often given without us even knowing, is what makes this whole revolution possible in the first place.
And that leaves us with one last really fascinating question to chew on. In an age where AI is becoming this indispensable partner in medicine, what does it even mean to be a doctor anymore? What is the essential role for that human touch in the art of healing? Something to think about.